Hi guys, welcome back to our lesson. So we are still looking at revising Euclidean geometry, right? So we did look at the midpoint theorem. Now we're going to continue with applying this midpoint theorem in trying to solve some questions. So let's just jump right into the questions. Now, when using the midpoint theorem, you need to make sure that you know you're going to use this either to find unknown sides and unknown angles, or to actually use it to find the properties or to prove the properties of quadrilaterals, right? Like, for example, prove that ABCD is a parallelogram. That's one of the ways you can use this. Now let's actually see what is it that we need to do in order to apply this. Now they say K is the midpoint of FG, of parallelogram FGHJ, right? Now as soon as I see the word midpoint, right, of FG, where's my FG? So it means that the two-liner there and the two-liner there means FK is equals to KG, right? And then this is a parallelogram. As soon as this becomes a parallelogram, it makes then the two opposite sides to be parallel and equal to each other. Now, GI is drawn parallel to KJ, right? GI is drawn parallel to KJ. If that is the case, it then kind of tells us already that this liner here will be equal to, let me make it three liners, will be equals to that one there, because you can apply the laws that have to do with the midpoint theorem. And then also it intersects Fj that is produced at I, which is just a point, and then prove that JH is equals to prove that JH is bisect GI, right? So we need to prove some equality there. The J and the G are really confusing at times. And then the note that you need to know before you can even solve this is the concept midpoint and parallel lines already tells us that there's a possible way of us using the midpoint theorem in terms of being an application of it, right? You also need to remember that in a parallelogram, the diagonals normally bisect each other. That is very key. Also, you need to know that you remember the 5 ways in which a quad can be proved to be a parallelogram. Now, if we apply the midpoint theorem here and look for a parallelogram, we can then claim that we know this Fj is equals to Ji there, because that's where the midpoint theorem will be. And if that is the case, it then means that Jk is half of Ig, right? Or Gi, rather, if we can use it like that. So that's one of the things we can talk about there. And then based on that, we can try and throw in some parallelograms, which I'm going to do with a broken line now. So we are going to prove that GH is bisecting JH is bisecting GI. Guys, this J and G are really, really confusing because they kind of sound the same at times. So if I want to prove that these are bisecting each other, that's JH there and GI. So this point here, it must be a point of bisection there, right? But now, what do I know so far? I know that this side is twice that side there, right? So if that is the case, then I will need to try and see whether JGHI is not a parallelogram or not. Because if it is, then I will have proven what they want me to prove. So automatically, based on that, I will just say, number one, I know that GH is parallel to JI, right? And that will be a given because it's a parallelogram, so this will be given. And then we also know that JF is equals to JI, and the reason for this will be midpoint theorem. Remember I said there's where we can apply it, midpoint theorem. And then based on this, we know that we can then say it means J or JI is equals to GH. Now, as soon as this is the case, it simply tells us that JGHI is a palm, right? Meaning parallelogram. The reason for this will be one pair of sides is parallel and equal. Let me just write that properly for you. It is one pair of sides parallel and equal. Based on that, then it is a palm, right? And then if that is the case, then it will be just that JH is bisecting GI. JH bisects GI. And then that will be the diagonals of a palm, right? Your reason will be diagonals of a palm, or just properties of a palm. And now they give us another shape, which is PQRS, which is a quadrilateral. It's not a regular quadrilateral, so that is the most interesting thing here. T, W, V, and U are the midpoints. I'm just going to stop there. I don't even want to continue. Firstly, it means T is the midpoint of PQ there. W is the midpoint of QR. V is the midpoint of RS. And then U is the midpoint of PS. You see, that's what they respectively means. And then I try to indicate them with liners, and then this is an X there, just to say they are equal. All right, so what they want me to now prove is to prove that TWVU is a parallelogram. So I'm just going to draw out the lines that are missing, which is the TW and the VU there. So as a result, you can see it makes it a not really parallelogram, a quadrilateral, which we need to prove that it is a parallelogram. To show you an actual visual of this, it will then look something like this with my dotted lines there, which are very beautiful. Now, what implicit information can I add? I actually want to add it on this diagram of mine. I know that TU is going to be parallel QS because of midpoint theorem. I also know that my VW is going to also be parallel to the QS. So meaning all three lines are going to be parallel one another, right? So in simple terms, I'm then going to say number one, TU is equals to 1/2 of QS, right? That's the first thing. And then I know also that my WV is also equals to half of QS. So in simple terms, it means that TU is equals to WV. And then my reasons for both these two will just be midpoint theorem, by the way. Midpoint theorem, right? And then now what have I done? I've proven that TU is equals to WV. Now what I need to prove is that the TU is parallel to WV. Then I will be done. So I actually did show you with the arrows, right? So we said TU is parallel to QS, right? And we also know that WV is parallel to QS. So as a result, it means that TU is parallel to WV. By the way, the reason for both these ones will also be midpoint theorem. Right? So let me just write the theorem at the top there so that people don't think it's there, right? That's theorem. I'm just shortening them because space might be a problem. And then lastly, then I can claim that this is a parallelogram. And my reason for it being a parallelogram will then be because one pair of sides opposite, one pair of opposite sides, right, are equal and they are also parallel to one another. That's one of the properties of a parallelogram. Please, I said you need to revise the 4 ways of proving that a quadrilateral is a parallelogram. All right, guys, I really hope now you understand how to use the midpoint theorem and when do you then use it? What must they tell you so that you know that I need to apply or use the midpoint theorem. Guys, I want us to take a quick ad break. When we come back, we're going to do one more question that is going to try and assist us in doing the application of midpoint theorem. Please stay tuned. I'll be back just now.